I'm here at Omlab's facility in Arnhem, the Netherlands. One of the most common questions I get about 3D printed concrete is about the environmental factors. And there's all kinds of concerns like the sand or the amount of cement that's sometimes used in these very fast curing, very buildable materials. And so today we're going to take a look at one of the few promising solutions for an bio-friendly, eco-friendly material that would be more sustainable. We're going to talk about some of the great possibilities and solutions with this technology from their founding team, a couple from the Netherlands. This material they've developed looks and feels like concrete, but it's actually made up of mostly calcium. So they take this byproduct from waste facilities and integrate it into their material. It makes up around 90% of the material composition.
My name is Margreet van Uffelen and
Huub Looze, yeah.
We're Omlab, bio-based design and project studio here in Arnhem, in the Netherlands. We started Omlab 1.5 years ago, and a year ago Huub invented the material prototype I'm holding in my hands now. That's when it all started, working on the circular and bio-based printing.
Yeah, we like to show the designers community and building community that you can make things with 100% respect to nature. The material started as a bio-based material, but we managed to make it completely circular too. And the technique we use, the 3D printing, gives us the ability to make better and functional stuff, objects, but also use less material and amaze people more. So they listen better and hear our story about how you can make objects that are really respecting nature.
Yeah. We
have to move towards this. And that's why we also share our knowledge about doing this.
Yeah, we're convinced that it can, that the building construction, etc., can be improved and be environmentally friendly, but it's way easier to do it the old way, and we have to experiment to do it a different way, and that's what we're doing here.
The chalk that makes it hard and white, calcite, yes. Calcite is carbon trioxide, but it comes from drinking water enhancement. So the drinking water in the Netherlands are infiltrated in the earth and then pumped up again to make drinking water. But then there's a lot of chalk inside. So they get it out, and we use it now as the basic ingredient. And then we put something in that's also very circular, and that's toilet paper. Toilet paper that ended up in the sewage, so it's really from the toilets, and then they sieve it out. And this cellulose is upgraded, but then we use it in our substance to make it printable.
Upgraded and sanitized, I would imagine.
Yeah, it's sanitized, yes. It doesn't give much problem, but you can
there's no smell.
Yeah. But cellulose has also often a smell if you make it wet. Like paper. If you make paper wet a little bit, you can smell it. But then there's another ingredient that makes a little bit of a smell, and that's the Calmera. And Calmera is something new. It's an invention of a Dutch professor from Delft, and he invented the process of making the sludge into a biopolymer. From the sludge they obtain a biopolymer that's also a binding agent for me, and it contains a lot different biopolymers and
aggregates or additives.
No. Proteins, yes. So it's organic, and this is something that creates the smell too. But it gives the material something very good strength, but also a balance in the material. So we're working on this recipe more. We really want to make it stronger, better, less smell, and etc. But it's printable. So we started 1 year ago, and being printable, we can create things we like. They look like concrete. They are tested already. It is challenging the concrete already. So yeah, we're very glad that we managed to make more and more complex models, like things for in nature. Now I'm working with a trainee who's going to do his final assignment here from the high school here, the University of Applied Sciences in Arnhem. And we together designed this sketch of a building block in which we integrate ventilation shafts. And
Quite
ventilation
nice.
shaft is like a tube. It's moving into the block, and it creates an opening there where we need it. Now we're going to design these building blocks more and more, and to show a great wall in Eindhoven.
Last year we presented a scale model of a tiny house, toilet space, and that was this size, this fragment. And then we heard very often the question, is it concrete? That's such an interesting question to find an answer to, that we developed a whole project and cooperation with companies, printing companies, concrete company, etc., to find that answer.
Yeah, now, Margreet is doing much of the research in literature and what you are doing, and publications.
Publishing, yeah.
Yes, and I'm doing the research on the working floor, in the workshop, and try to find the experts to together make the 3D prints possible and the recipe better. The printing with this material, we hope to give examples in which companies that are 3D concrete printers think of, yes, that's what we want to, because it's much better than printing concrete.
Yeah.
But the challenge for us now is to manage disadvantages of this past, to compensate them with technique. And I'm working on it that with maybe you know it about Rhino 3D and Grasshopper. You can manage to code a form and then control the printer even better. And we are now trying to find a way to make the form more complex, but without losing control of the paste. And
that you can show that with this corner.
And thanks to techniques like Grasshopper and the good slicer technique, you can use other materials. Concrete printers are often taking the escape to use a very fast hardening mortar, and that's something that uses a lot of more chemical ingredients that are not respecting nature. So there are other ways to solve this problem. We have to put more effort in finding a solution to this. Yeah, and one of the things we use is cellulose, or This cellulose is a resale.
I'll get the other ingredients.
Yeah, this is a very fine one. I have to do some experiments with this. And it's old toilet paper. Yes, it's fine one. And this is the less fine one. It's all from drinking water, yes? And then the cellulose, and this is alginate. Alginate is binding stuff. They also use it in food processing and medical applications, but also in industry like carpentry, etc. And this is the Calmera, the Dutch invention with biopolymers. It has different
This is this one.
qualities, this material. Yeah, it's quite dark and smelling. I always see this whole process of mixing as something we are in the beginning with. Material mixing is comparable with the development of concrete and paper, and I think we need a lot of time more to develop this with these ingredients into something really strong, but it's a start, and we need a lot of years maybe, but in 1 year we achieve to make this complex things. So I'm encouraged to go on with this. This is our mixer. It's from clay technique. So we put the dry stuff in this, and then we mix it until the right mix. You add water and the Calmera, and then we put it in our cartridges we use in the printer. If we enlarge this, we have to make this a lot bigger. But this we're going to start with in summer, together with other companies. But then this is a good start. We have control. We write a protocol to mix this and to have a constant quality of the material. We made a stool to show people that you can sit on it after it has been printed.
We received we were the winner of the prize of the
public.
public. So people are very interested in this.
Now we're working on two directions. You can make this material very strong and resistant, and you can build with it. But on the other hand, we're working on a recipe that is interesting for nature in another way. We can make this recipe that it is biodegradable too. So we can make biodegradable complex objects that are interesting for plants and animals. And that's what we're going to show on an exhibition next week.
Yeah, this one.
This is a small object, like a rock you find on the pavement. But we want to enlarge it, maybe with 20 additive manufacturing, by rolling up a rubber track with a caterpillar, yes, with a robot printer arm on it, and then go into nature and print it 5 meters in diameter.
That's the idea.
That's the idea. Yeah. So, yes, and then it will give nutrients, seeds and chalk to the nature. Industry is changing the earth a lot, so it needs a lot of chalk, and this will help the environment to become better.
Yeah, and this is the same recipe of which we published last year, and which we used for the small space. So in the meantime we developed it further, but this is the biodegradable one, and non-coated.
Yeah.
It's
non-coated.
Yeah.
Just
it releases the calcite, the chalk, very slowly.
Infill here and sees all the parts the printer did run. But this is something normal 3D concrete printers don't like. They don't like to make this, and they don't like to stop printing and then start again. A lot of them can't manage it. So we need an advanced 3D concrete printer, and it already happens, but there are a few who know how to do it. And the other thing I'd like to develop is non-planar printing. So we can use all the advanced techniques to make it even better. So the past is under control right now, and now I'm on the moment of making the printing software better and controlling it even further. This is something, another direction we are trying to engineer. This is a design for acoustic panel. We'd like to cover a big wall with these kind of forms. Acoustic panels have two functions: to spread the sound and to absorb sound. So they reflect it in different directions, then you have less reverb. But the other thing is to absorb it, and then you have to fill holes with a damping material. There are a lot of materials from recycling also, from cloth and etc. to put in and then have absorption in it. So this form is one of them, and it's inspired by the sewage sites. We can give you an example. So we're searching for a form, but there are a lot of possibilities, and you see also that these forms all start-stop problems we managed, no problem. This is another example, or this is the material we put in. This is the absorbing material, and it's designed by Rick Almans, yeah. And we developed it together to, we're working on printing it in big size. We'd like to make studies in plastic and then enlarge it. So it's also PLA, of course. We don't like other plastics. The thing about this material is that it needs to cure by evaporating water. And that's something we have to solve a little bit more. And the thing we're working on right now is to print it on a laser cut tablet sheet to be able to ventilate it a lot. Now working on drying it with infrared with a high frequency, so it enters the objects a lot, and then it dries even better. Without it, it cures slow, like 3 days or more. It depends on how thick it is and how less air can go through it. But if we control it, we cure it in 1 day. And then it's more suitable maybe for prefab sites. But if you manage to make ventilation shafts on an on-site printed object and some infrared panels with it, then you can cure it also on-site. So we're working on it. We will go into these experiments in a few months.
If it's biodegradable, how well does it hold up in the weather, like the rain outside?
There are different ways to prepare it with, and one of the physical properties of this alginate and chimera is that it becomes water resistant if you treat it with calcium ions. This salt is curing it on the outside, and if it's cured on the outside, you can treat it with something like linseed oil or another bio-based biopolymer, and then it will be resistant to all weather.
Are you guys seeking any investors at this point?
The way we are working is we set a goal. We want to make an impact with for building, but also for biodiversity with the old recipe. That's one focus. And now we're focusing on the building blocks, and we set a goal, printing bigger, making it easier, and for instance more water resistant. And that goal we're trying to work towards via different tryouts, different research, but through assignments. For every goal, the smaller goal, we have a cooperation with a company, and that way we focus on this, then we focus on that, and then we're getting there. So and in the meantime, maybe there's going to be an investor, so we can really make it bigger when we have the real egg of Columbus. And but at the moment we're thinking about some ways to find the right investor for the right moment, but not there yet.
Our project starts with asking, are you willing to spend a little bit more than normal getting an object, but invest also in partnering and doing research?
Yeah.
And that's not, yes, here you have some money, go on. No, be part of it, and be, how do you say, betrokken? Committed, yes.
Yeah.
So committed investments, yes.
Yeah. Call, email, all the info is on the website.